Right, this is a quick demonstration of how I use Maxim to spot novas in M31. I've just loaded my reference image, which was taken a long time ago. It's quite a good quality image. The stars are reasonably round. There was good seeing on that night when I created these. It was on August the 26th, I think last year. It could even have been 2017. I then load the new images, which in this case is this one here, where I stacked 7 10-minute images together, and we can see there they both are. Now the first task is to align them so that each star occupies the same place in each frame. For example, if I move this image up to the top and over to the left and have a look at this one, go right up to the top, which it is, and right over to the left, then we can see, for example, this star here is a little bit over from the edge. That one is much closer, so the stars in this image are shifted over a bit, and if we look up at the vertical side of things, quite clear to see that this star here is not in the same place. So we need to align the images. That's done by process, align, choose both, okay, and then it does an astrometric determination to find out the true position of all the stars. Click OK, and that is done. If I were to mess around here, you could see now that these stars are more or less in the same place. I think you might see that the distance from the corner of each of these stars is now the same in both images. I can adjust the brightness there to make them look a little bit similar, and you can see it's put a black stripe down the edge of this image. If I exaggerate that, there we go, you can see it's put a black stripe down the edge there. It's shifted the image over. That has worked out quite well. Next process, pixel math. What we do is we take each image, load it in here into the pixel math setup. I always put the test image as image A and the new images in image B, and the reason for that will appear in a little time. Now you can't see much here. What it's doing is it's removing one image from the other. So if both images were exactly the same, you would just have a black screen, but I haven't got the screen stretch sorted out. So if I move that over to there and the maximum marker over to there, I like to try and work for a reasonably uniform grey background. Here we can see that the stars are now half black and half white. What it does is it subtracts the one star from the other. If the shape of the star, the circular object, or the circular shape of the star was exactly the same, you wouldn't get that. But stars twinkle, their shapes are slightly different, and so you never get totally uniform subtraction. What I can see is that sometimes the stars look a bit different. This one, for example, I know is a variable star. This star here goes up and down in brightness, which is why if you compare it to one of the same sort of size, that's an ordinary star. Those three there are fairly ordinary non-variables, steady stars, but that one I know is a variable, hence the increase in black. This one here as well, I have investigated. That one goes up and down in brightness, but here we can see something which looks very different from all the other objects. It's not black and white, it's completely black. It needs to be round If it was a great streak, then maybe that would be cosmic rays or something strange. So that is definitely something that's appeared on the second image that was not there on the first. Now if I'd had these the other way around, with the reference image as B and the test image as A, then the new objects would be white. I'd be looking for white, but I find black, it gives so much contrast that it's much easier to spot. So that object is worth remembering. To come and have a look at that. So I'll click OK there, and I can then edit, annotate, choose a little circle and put a white ring around it so that I can come back and have a look. What you can see here is a little white dot, and I've put markers on that already because that is an old nova that was around months and months ago. It showed up on my reference image, and therefore every time I used this method I would see a white star there and think, what's going on there? So to avoid that confusion, I mark it. And there's another one down here that I find, that's a variable star. It was very bright on the test image, it's completely disappeared now. So to avoid confusion, I put markers on it. Now this method is really good for things near the center of the galaxy, because you can adjust the brightness so that you can see quite close, and therefore that as I said before, that bit is completely burned out. We're never going to get any information from that. A 10-minute exposure will always saturate the core, but any novas around this area would show up. Not these things, which are caused by sort of gas clouds. If you know what the gas patterns are, all of these streaky things, the gas clouds seem to vary in brightness due to sky conditions and things. So when you subtract one image from another, they never disappear, that you get the remnants, but it's certainly not a circular object looking like a star like this and this. So what are those? Now I know for certain that was a nova discovered a few days ago, but this object here was not an old nova. It is definitely something new. So I would want to edit that one and definitely put a circle around that, and I shall do that one there. I think I might have lost that one. Yes, I didn't make that permanent, so circles around all those three, and if I click on OK, they should remain. I can then save the image. I call it something like File, Save As, and it's calling itself Group 3 there. I'll just call it Possible Nova for the time being, and therefore it is now saved. I can go and check positions to get astrometry. You can't get with Maxim an accurate coordinate reading for new objects, which is a bit of a shame. I would use a different bit of software for that, which I could quickly show you. If I minimize that, it's called Astrometrica, which I will load up now, and this is an extremely useful bit of software. I will load up there the same image. It puts it into a negative format, which again can be quite useful. You then go up to this little button and say astrometric data reduction. Don't worry about exactly what it's doing here. It's now going through the image, comparing it with a catalogue of stars, looking for stars that it knows all about, and when it has finished, there you go, it's put a little dot. Sometimes you have to tweak the position a bit with these arrows to make certain that each circle and dot is actually lined up on a star, which it has done extremely well, and then click OK. Now that object that we were looking for, the one over to the side, I probably would forget which one it was, so I'd look at my other image and test it, but I know where that new one is, so I'll just enlarge the image, and you can see that it's very, very dark towards the center here. I can change that with adjusting. Now, rather than pulling these sliders around, it makes it easier to just go up to say 20,000 there, and have a little look. We can now see much closer to the core of the galaxy, and I know that that object there, you might not see this too well. I might be able to make this perhaps a bit darker. So if we go in, showing up a bit better, in a little bit more, yeah, there it is. That little grey dot is the new object, the nova that we're looking for. The other one I think is up here somewhere. It's quite difficult to spot, so I'll click that with a little, I'll just move actually over to the side here a bit. So there it is. Click the cursor on it, and hey presto, there it is. It will quite nicely tell me the time that I've got recorded for the image, 18:07:21, 7 minutes past 6, which is, it's getting that time from one of the 7 images that I stacked, I think, because I think if I investigate the first image of the sequence, it was 2 minutes past 6. Here it gives you the coordinates: right ascension, hours, minutes and seconds, and declination, hours, minutes and seconds, and an estimate of the brightness. Now that's very difficult. I don't trust that at all, because right near the core of the galaxy here, it wants to look at the brightness of the star and compare it to the background, but half the background is made up of light from the core, so I would not believe that completely. But obviously if I have another chance to look at this nova, I can see whether it's brightened or dimmed. Another little trick I sometimes use is to mark it by calling it nova. It likes 6 characters, so dash nova dash, and pop accept, and there it is. It highlights it. Click it again, and then I can do a screen grab of that to let anybody who's trying to confirm the image, or in days to come, it helps me work out where the thing is, because sometimes they form nice little patterns. This is a nice little trapezium pattern here, or 2 dots with a bow of dots. The brain quite likes to make up patterns. So I could probably remember that nova from this curve of stars here, and with 2 stars, well, there's 1, 3 stars along the top. So that is a little outline of how I set about determining what is what.